Take a simple metal spoon and place it next to a wooden stick. One conducts electricity instantly, the other doesn't. They sit close to each other in the periodic table, yet behave completely differently. That difference isn't magic, it's a pattern, and once you see it, the periodic table stops looking random and starts behaving like a map. Let's go a little deeper. The periodic table isn't arranged alphabetically or randomly. It's organized by atomic number, the number of protons, and as you move across or down the table, certain properties change in very predictable ways. These changes are called periodic trends. Here's the first one: atomic radius, the size of an atom. Imagine stacking floors on a building. As you move down the periodic table, atoms get bigger because they gain more electron shells. More shells means electrons are farther from the nucleus. But as you move across a row, atoms actually get smaller. Why? Because the nucleus pulls electrons inward more strongly, squeezing the atom tighter. But wait, here's a twist. A stronger pull from the nucleus doesn't just affect size, it affects how hard it is to remove an electron. This brings us to ionization energy. Ionization energy is the energy needed to remove an electron from an atom. Atoms that hold onto their electrons tightly have high ionization energy. Atoms that lose electrons easily have low ionization energy. That's why metals on the left side of the table react so easily. They're desperate to lose electrons. And nonmetals on the right resist losing them. They hold on tightly. Now here's something even more interesting. Some atoms don't want to lose electrons at all. They want to pull electrons toward themselves. This ability is called electronegativity. Imagine atoms playing tug-of-war with electrons. The stronger atom pulls harder. Elements like fluorine and oxygen are extremely electronegative. They grab electrons aggressively. That's why they form strong bonds and drive many chemical reactions. Let's connect the dots. As you move across the periodic table, atomic size generally decreases. Ionization energy increases, electronegativity increases. As you move down the table, atomic size increases, ionization energy decreases, electronegativity generally decreases. These trends explain why elements behave the way they do, why some react violently, why some barely react, and why some form incredibly strong bonds. Before we wrap up, zoom out for a moment. Every battery, every chemical reaction, every bond between atoms follows these trends. The periodic table isn't just a chart, it's a prediction tool. Once you understand the trends, you can predict behavior without memorizing anything. And that leads to the next question. If atoms follow these trends, how exactly do they use electrons to connect with each other? Why do some share electrons while others transfer them completely? That's where everything comes together in the next video on chemical bonding.